Hello and welcome to UGCE PG Pathshala. I am Anushri Nagpal from the Department of Geography, Jamia Millia Islamia. I am presenting this module on behalf of Dr. Ramashri Prasad. In this episode, we will learn about temperate cyclones, which comes under the paper Climatology. Learning objectives of this particular module are: first, you will be able to define cyclones. Second, explain the origin and development of temperate cyclones. Enumerate the characteristics of temperate cyclones. Explain the changing weather conditions during the temperate cyclones. Explain the reasons for the development of cyclonic conditions. And locate and demarcate the distribution of temperate cyclones on the world map. Introduction. We all experience different kinds of temperature, humidity, cloud-cast sky related to weather phenomena every day. Have you ever noticed that there are changes in pattern of weather events in an annual cycle? Depending on where you live, there could be different reasons for that. You have already studied about the planetary wind patterns and shifting of wind belts. You are also well aware about the air masses and front formations. These atmospheric phenomena in the mid-latitudes create conditions for the development of cyclonic conditions. Whenever they develop, numerous changes are observed in a shorter span of time, say a few days or a week. They are termed as temperate cyclones or frontal cyclones. This module discusses about the development of this cyclone, the associated weather and their distribution over the globe. Temperate cyclones. A temperate cyclone is referred to as mid-latitude depression, extratropical cyclones, frontal depressions and wave cyclones. Temperate cyclones are active above mid-latitudinal region between 35 and 65 degrees latitude in both hemispheres. The direction of movement is blow from west to east and more pronounced in the winter seasons. It is in these latitude zones the polar and tropical air masses meet and form fronts. Most of these cyclones form at wave-like twist or perturbations on these fronts. On a weather map, cyclones are shown as low pressure area enclosed by a number of isobars, circular or elliptical in shape. It is also referred to as cyclone or depression. When these isobars take an elongated shape, the pressure system is called a trough. These cyclones are mainly observed in Atlantic Ocean and Northwest Europe. These cyclones have characteristics to develop over both oceanic and land surfaces. Much of the highly variable and cloudy weather come across in the temperate zones. Since mid-latitude is an area of convergence of different air masses, it leads to the formation of fronts as well as the cyclonic conditions are bound to happen. Fronts. Air masses have been dealt in module 21 and you know it very well that the air masses develop in specific regions over uniform physical properties including temperature, air pressure, humidity, etc. They have similarity in terms of air pressure, horizontal temperature and moisture distribution. Based on temperature characteristics, air masses are of two types, warm and cold. Both of the air masses march forward and both of them converge. The convergence is known as fronts. Critchfield defined front as sloping boundary surface between contrasting air masses. Stroller and Stroller define the front as sharply defined boundary between itself and a neighboring air mass. According to Oliver and Hidor, front is identified as a zone of transition between airs of different properties. In a very simple term, front is a narrow zone between two different air masses, like a frontier when the armies of two countries come to fight each other. As mentioned before, air masses are of two types, warm and cold. Two types of fronts with distinct characteristics are formed in the process of marching forward and getting interacted with each other. Later on, the intermingling of the two gives birth to another one known as occluded front. Warm front. In the northern hemisphere, the warm front develops to the southeast, to the right side of the moving direction of warm air masses. In the southern hemisphere, it develops to the southeast, to the left side of the moving direction of warm air masses. The warm front development is caused and modified due to the interaction of the air masses. On the warm front, the effect of warm air mass is pronounced and hence it is named so. Cold front. In the northern hemisphere, the cold front develops to the northwest, to the right side of the moving direction of the cold air mass. In the southern hemisphere, it develops to the southeast, to the left side of the moving direction of cold air mass. The development is caused and modified due to the interaction of the air masses. On the cold front, the effect of cold air mass is marked and hence it is named as cold front. Occluded front. Occlusion means the blocking or sealing the existence and with respects to front. It signifies the removal of the fronts from the ground. Occlusion of the fronts occurs when the cold air mass occupies the ground space surrounding the hairpin turned clubbed warm and cold fronts. This type of fronts do exist but for short time. They remain on suspension in the sky. It is termed as occluded front. Origin and development of temperate cyclones. The most significant and lasting contribution to synoptic meteorology towards the end of the First World War was made by the Norwegian meteorologists associated with the Bergen School of Meteorologists. Wilhelm Birkens, his son J. Birkens and Associates. They brought about major advances in understanding the temperate cyclones. They focused on careful, systematic analysis of synoptic weather maps and time cross-sections of weather systems. They identified and developed first model for the life cycle of mid-latitude cyclones, being associated with the development of an occluded front, wherein the mid-latitude cyclone's cold front overtakes its warm front. Their investigations and researches resulted in explanation of the polar front theory of cyclone or simply wave theory. The origin and development of temperate cyclone is best explained by the Norwegian model. It is very popularly known as the polar front theory. The polar front theory. According to this theory, the warm, humid air masses from the tropics meet the cold, dry air masses from the poles, and thus a polar front is formed. It creates a surface of discontinuity between two air masses. Such conditions occur between subtropical highs and subpolar lows. The cold air is denser and heavier as the intermolecular space of the cold air is smaller. It always occupies the lower ground space. Due to this reason, warm subtropical air is pushed up. There is interaction between the two air masses depending upon their nature in terms of temperature and moisture conditions. This interaction of cold and warm air masses creates instability and the low pressure is created at the junction, particularly in the center of the interactions. The center of interaction is that zone where the cold and warm fronts are differentiated. Later on, this point develops as the eye of the cyclone. The formation of wave is indicative of thermal contrast. The two air masses start encroaching the domain of each other. In the northern hemisphere, the warm air mass moves northwards as westerlies. The cold air mass moves southwards as easterlies. Since it is the case of northern hemisphere, winds are bending to the right direction as per the Ferrel's law. In this process, both westerlies and easterlies are deflected to the right from their designated direction. Therefore, along the front, creation in the northern hemisphere, eastern part of the front is dominated by the warm air mass. On the contrary, to the western side, the dominance of the cold air mass is prominent. The reverse is the case if we take the example of southern hemisphere. The successive development of the mid-latitude cyclone may be explained through the following stages. Stage 1. Stationary or the beginning stage. Stage 2 is a beginning of young adult. Stage 3 is a mature stage. Stage 4 is the occlusion stage. And stage 5 is the dissipation stage. Stage 1, which is the stationary or the beginning stage. The cold air mass and warm air mass tend to converge along an axis. The sequential development of temperate cyclone can be seen in the figure on a three-dimensional configuration. In this situation, both of the air masses are almost stable and are in contact with each other. It is also known as the stationary stage of the front formation. Though the difference in temperature, moisture and pressure remains marked between the two air masses, still it is not that great to create instability at a bigger scale. With the passage of time and with interaction between them, particularly in the fringe margin of the contact zone, there starts some push by warm air mass to the eastern side, and to the western side the impacts of the cold air mass is distinctly visible. At the latter phase of the stage, the straight and flat formed front is turned by the advancing air masses of their influence and is clearly visible in the figure. After this, the second stage of the beginning of the young adult starts. Stage 2, beginning of the young adult. By the end of the first stage, the frontiers of the two air masses are conspicuously different. First, where the greater impact of warm air is observed, it is warm front and it lays to the eastern part in the northern hemisphere. The impact of cold air mass is very significantly seen in the western part of the northern hemisphere. To the north and northwest, the area occupied by cold air mass is known as the cold sector. Opposite to it, that is south and southeast, the area is dominated by warm air mass and hence it is known as warm sector. It is all happening under the general principles of the winds associated with Coriolis effect and the Ferrel's law. A mirror image situation is applicable in the case of southern hemisphere. The warm front has more instability because impact of more moisture is found within it. Contrary to this, along the cold front, the stability is relatively greater as the cold air mass has less moisture. Previously, you have already read about the instability in the air. You also know that addition or availability of more and more moisture causes the air to be more and more unstable. At the junction of the two fronts, warm and cold, the instability is greater. The cold air mass tries to push the warm air mass, and in this process the junction becomes more and more sharp. The warm sector starts shrinking and the turn of the bend becomes more sharp. Since the warm air mass is lighter in density and therefore is pushed up on the cold air mass, rising warm air with moisture cools down under the influence of cold air as well as increases in height. The condensation is evident. After the precipitation, latent heat is released and further low pressure is created over the junction of the two fronts. It is the beginning situation of the tropical cyclone formation. Since the cyclonic condition is already initiated by the end of this stage, that is why this stage is known as the beginning of the young stage of the temperate cyclone. Stage 3, mature stage. By the end of the second stage, the low air pressure has already initiated at the junction of the two fronts, particularly due to condensation. That low pressure attracts air from the surrounding region and a vertical updraft of the air is observed very significantly. In the third stage, the intensification of the second stage is resulted. Due to the intensification, the isobars become closer. The pressure gradient becomes very sharp. Swiftly updraft of the air moving in a whirling manner. The invasion of the cold air mass is greater. Warm sector becomes still smaller and shrinks. More and more sharp turns of the two fronts are seen. That creates the real and advanced stage of the temperate cyclone. Since the general patterns of the winds are westerlies, the temperate cyclones are in a tendency to march towards the eastern side. Therefore, wherever it strikes, it brings changing weather conditions. By the end of this stage, the combined front starts to get lifted above, and it is the beginning of the diminishing stage of the cyclone. Stage 4, beginning of occlusion. The literal meaning of occlusion is constriction or compression. The two distinctly formed fronts are getting compressed because of their diffusion. By the end of the third stage, both fronts were coming closer and finally they culminate into merging together, which we call the occluded front. In occlusion stage, the cyclone starts declining as the low pressure gets weakened. The intensity is lowered and the wind velocity is on decline. The convergence of the two fronts gets detached from the ground and are still suspended in the sky. Ground level in the beginning was occupied by the two different air masses, but now after occlusion, it is the occupation of the cold air all through on the ground. Clubbed fronts are still hanging in the sky. Warm sector has been shifted above the ground. Discontinuity is still there but in the sky and not on the ground. Stage 5. Late occlusion or dissipation stage. In the beginning stage of the occlusion, the temperate cyclone was still very dynamic and strong, but by the end phase of the occlusion, it is substantially weakened. In the last stage of cyclone, more and more areas are occupied by cold air mass. It happens so because it is much dense and heavy in comparison to warm air. Warm air areas are completely governed by cold air. The pushed up warm air cools down under the impact of cold air as well as by adiabatic cooling. By the end of this stage, the low pressure is completely eliminated and the normal condition is reached. Even the occluded front is pushed up and is completely removed. All these conditions are the characteristics of the dissipation stage. Summing up of the different stages. All the stages discussed above develop in a sequential order, one after the other, starting from the simple convergence of two air masses to the modification depending upon the temperature, moisture and air pressure conditions. The typical development of temperate cyclone over North America is clearly shown in the figure. It is showing the direction of winds, front formation, front modification in different stages, cyclones' isobaric pressure variations. From the development to dissipation stages, changes over a period of 8 days is quite clear and vivid. Characteristics of temperate cyclones. Location. Temperate cyclones exhibit wide variety of characteristics. They are formed between 35 to 65 degrees north and south latitudes in the subpolar frontal zone, and this is a result of interaction between cold polar mass and warm tropical air mass in the westerly wind belt. This type of cyclone is more pronounced in northern hemisphere due to greater temperature contrast created by land-water distribution. Climatologists suggest that globally mid-latitude cyclones predominantly form in one of two locations: downwind of major mountain ranges and near the eastern coastlines of continents. Formation. The formation of temperate cyclones is predominantly controlled and dominated by the formation of the fronts after coming into contact of the two different air masses, warm and cold. Thermal contrast of the two types of air masses is a genesis for the development of low pressure center and finally the creation of temperate or extratropical cyclone. Their occurrence are possible over large areas characterized by land or water or at the joining places of the two. Velocity. The temperate cyclones are formed over a very large area. The development of low pressure is not very intense. The isobars are relatively wide apart and therefore the pressure gradient is smaller and hence the velocity is moderate around 30 to 40 km per hour. Frequency. Since the temperate cyclones are formed due to front formation, they are occurring throughout the year. Therefore, they are not confined to any particular season but are their frequency is less during summer in comparison to winter. Aerial coverage. The temperate cyclones develop over a very large area, occupying more than 1500 or even sometimes more than 2000 kilometers in diameter. Its vertical dimensions reach up to tropopause limit. Air pressure. As mentioned above, the air pressure gradient in temperate cyclones is gentle as the isobars are widespread. Hence, the intensity of the winds in this type of cyclones are moderate. Generally, the isobaric difference varies between 10 to 15 millibars. Direction of movement. Since the temperate cyclones are developed in the mid-latitude areas where the westerlies are prominently blowing, the direction is in general from west to east. Due to Coriolis effect, the direction is not straight from west to east but follows the path from southwest to northeast in the northern hemisphere. In the southern hemisphere, it is from northwest to southeast direction. Therefore, they move from mid-latitude areas to high-latitude areas. The direction of the tracks of this type of cyclone is governed by the surface roughness and the characteristics of the areas from where they pass. In general, it is curvilinear direction that they follow. With the passage of the cyclonic tracks, they get reduced, fronts weakened, and finally they dissipate. Weather conditions in a temperate cyclone. Weather in warm front. March forward of the temperate cyclone is marked by arrival of the warm front first towards the cold prevailing areas. Increase in temperature is observed very clearly. Since the warm air in general has greater amount of water vapor, the condensation is evident and more rainfall or snowfall is recorded. The temperate cyclone is slow in its velocity, therefore prolonged moderate precipitation is the prime characteristic. As long as the warm sector prevails over the areas, the warmth continues. Weather with cold front. With the passage of the warm sector eastward, further is marked by the arrival of the cold front. Cold front arrival is associated with lowering of the temperature because of the prominence of cold air mass. Since this front is again the combination of the two air masses, here the warm air effect is less and that leads to less amount of water vapor. Concentration. Cooling is of warm air also causes the condensation. Therefore, the precipitation is less in comparison to the warm front passage. Generally, cirrostratus, altostratus, nimbostratus and stratus clouds are seen. Therefore, halo around the sun and the moon becomes very distinct feature in temperate cyclones. The central part of it is known as the eye of the cyclone. It is relatively cool and calm. The sky is clear and updraft of the air is observed. Precipitation. The precipitation is dependent upon the availability of water vapor and the prevailing temperature conditions. Therefore, the type of precipitation varies from rainfall to hailstorms. Though the hailstorms are not a very regular feature and sometimes associated with thunderstorms. It occurs less frequently, but the rainfall, sleet and snowfall is common. As mentioned before, the temperate cyclone is huge in size in terms of areal expanse. Its passage also takes longer duration. The precipitation occurs for a longer duration. The weather associated with both fronts and their movements have been summarized briefly in the table. After the occupation of warm sector by the cold air masses, the normal conditions prevail. It shows clear sky, less air temperature. At this stage, a uniform condition is applicable to the air mass. This uniformity is found in terms of temperature of the air and its pressure. Finally, it becomes an air mass with distinctly uniform temperature, pressure and humidity. This is just like the initial stage of the development of the temperate cyclone. World distribution pattern of temperate cyclones. As discussed before, that the temperate cyclones develop in the mid-latitude areas of the world. This area is also known as the extratropical. Therefore, extratropical cyclone or temperate cyclones both represent the same thing. Temperate cyclones are found primarily between 35 to 65 degrees north and south. Their tracks are found to be even beyond 65 degrees of latitude in both hemispheres. The tracks of the temperate cyclones are shown in the figure. From this figure, it is obvious that the direction of the cyclone and their tracks follow the easterly direction, which has already been mentioned before. In northern hemisphere, it is from southwest to northeast direction, whereas in the southern hemisphere, it is northwest to southeast direction. The occurrence and distribution of temperate cyclones show a very well defined zone over the map of the world. Temperate cyclones are found almost all through the year with more or less seasonal variations, but they are more frequent in the winter season because greater temperature contrast is seen during this time. Hence, winter is the ideal period for the formation of temperate cyclones and their frequency is also greater at this time. There are three important zones for the development of temperate cyclones in northern hemisphere: the Atlantic Arctic front and cyclone. The North Atlantic is much warmer while the Arctic air mass is very cold. When both of them are coming into contact with each other, the strong temperature contrast is created and strong low pressure formation is resulted. It causes to move the cyclone towards the northeast direction and reaches up to the Western Europe. North America polar front and cyclone. The air mass of North America and North Polar air masses converge, cause a cyclone to develop, particularly in the Great Lakes region, and move towards the northeast. Mediterranean front and cyclone. The third important area for the development of temperate cyclones is the northern hemisphere, is a Mediterranean Caspian front region. Huge expanse of the continental areas to the north of Mediterranean Caspian paths and their relatively warmer air mass over these seas creates the fronts. Along this front, the extratropical cyclone is generated and moves in the general direction of the wind of the region. The lighter shower in the winter over northwestern parts of India is caused by the western disturbances coming from this zone. Extratropical cyclone in southern hemisphere. The southern hemisphere does not have big land masses for creating temperature contrasts. Therefore, there is no specific region for the development of extratropical cyclone. They are developed with lesser intensity between 35 and 65 degrees south latitude and travel in southeasterly direction. Summary and conclusion. Temperate cyclones develop between 35 and 65 degrees latitude in both hemispheres. Poleward parts of this limit are very cold, while the equatorward limit is much warmer. Both of these regions have different types of air masses. When these air masses come into contact with each other, they form a front, a distinct boundary between the two. The intermingling and interactions between them creates disturbances, leading to the tropical cyclone. This interaction is through the fronts, warm and cold. Along the warm front, the prominence of warm air mass is dominated, while along the cold front, the prominence is of the cold air mass. The concept of this type of cyclone is explained by the polar front theory, popularly called the Norwegian model of tropical cyclone. The growth and development of this cyclone is explained through successive 5 stages of beginning, adult, mature, occlusion and the dissipation stages. The main characteristics of temperate cyclones could very well be seen in terms of its location, formation, velocity, frequency, air pressure and direction of its movement. Weather conditions associated with warm fronts, cold fronts and precipitation is quite distinct. Apart from all these, temperature, humidity, dew point, types of clouds and visibility are some of the other parameters of associated weather during the temperate cyclone. The distributional pattern of temperate cyclone is very distinct, particularly in northern hemisphere. It happens because of the land-water contrast and greater temperature variations. Its frequency is more during winter season than the summer. Southern hemisphere has more water body and the temperature contrast is relatively less, and hence the extratropical cyclone is not confined to a certain region or a pocket. But in northern hemisphere, its major areas of concentration are Atlantic Arctic belt, North America Great Lakes belt and the Mediterranean Caspian belt. Thank you.